Hello, and welcome to Team Alpha's minimal increment demo of the Clueless board game for the Foundations of Software Engineering course at Johns Hopkins University for the spring 2025 semester. In this presentation, my team members and I will build off of our skeletal increment demo, providing updates to our organization and communication of subsystems, our risk assessment, our intended schedule and expectations for the remainder of the semester, and an updated video demonstration showcasing our progress so far. Here in this slide, I'd like to provide a brief overview of the group members, their different roles, and an overview of the product being designed this semester. In regards to the group introduction, Ria is the program manager. As the program manager, Ria is responsible for overseeing the project timeline, ensuring collaboration among team members, and maintaining project efficiency. The program manager monitors project milestones and ensures that tasks are completed on time. Josh is the lead architect. As the lead architect, Josh is responsible for designing the general system architecture. The lead architect coordinates with the other developers to ensure that the team understands the general architecture and follows its structure. Hyunjin is the lead tester. As the lead tester, Hyunjin is responsible for ensuring the game functions correctly by thoroughly testing inputs, outputs, and interactions between subsystems. The tester will verify that each system processes given data correctly and produces the expected results. The tester will also identify and test edge cases, uncommon or extreme scenarios, in the program. Paul is the lead programmer. As the lead programmer, Paul is responsible for overseeing the development of the game's core systems, ensuring performance, scalability, and maintainability. The lead programmer guides the other developers, monitors tasks, and ensures coding best practices. Leah is the lead software quality manager. As the lead software quality manager, Leah is responsible for ensuring that the game meets the project standards by reviewing testing strategies, documentation, and code implementation. In regards to the actual product, the product this team is creating is a simplified version of the popular board game Clue. While this version of the game has the same 9 rooms, 6 weapons, and 6 characters as the original game, the main difference is in navigating the game board. The Clueless board game can be divided into 3 subsystems. The first is the game logic. This subsystem defines the functionality and operation of the game to include such features as moving players around the board, validating player actions, keeping track of whose turn it is to play, and checking the current game state. The second subsystem is the network, which handles communications between the players, the game server, and the database. The network processes game logic and incoming requests from players, such as when a player makes an accusation or suggestion or attempts to move to another room or hallway. The third subsystem is the database. The database keeps track of all information regarding the game and the players in the game. It also maintains and updates that data throughout the game's progression.
Hello, I am Paul Bogner, and like in our skeletal demo, I will discuss our subsystem communication setup. As mentioned before, we have our Redis server. Redis is used as a message broker to handle real-time communications for the WebSocket connections, and will play host to our network's subsystem server side. There's also Daphne, our ASGI server for the HTTP and WebSocket protocols. Daphne is an asynchronous server that allows for the real-time nature of the game. That will also be a part of our server-side network subsystem. And last, there's our Python Django server. Python Django serves as the main application server, handling HTTP requests for player login, game state retrieval, as well as the game's main page and login/setup functionalities. Within Django, our game logic, database, and our client side of the network subsystems can be found. Our subsystem communications remain the same as before. We have our game logic and network, having communications to send game updates to the clients and receive player input, along with the network to database communication for retrieving and storing game data based on players' actions and the current game state. And lastly, we have our database to game logic communication to determine truth for initializing the game and any actions taken. As an example of this communication for our minimum increment presentation, we'd like to go over a player making an accusation. So step 1, the player must click the accusation button found on the top of the game board. This will prompt the user to fill out the information for the accusation and then hit submit. It then passes all that information to the game logic to validate that it's a possible action that they can take. If it's not, it'll give them an error message and say, cannot perform that action at the time. But if it is valid, it will then update all of the game logic by updating some of the character values signifying that they have made this action. Once all of this is updated, it then is broadcasted out to the network to inform all of the other players.
Hello everyone, my name is Hyunjin Kim. I'll be presenting our risk assessment and schedule updates. Our minimal system already meets core requirements, but as we enhance it with dream features and system quality improvements, we've identified 4 key risks. Let's dive into these risks and how we plan to address them. The first risk is the unfinalized database schema for dream features and system quality with a high impact and high probability. Schema changes for these enhancements may require migrations, impacting the team and delaying optional milestones. To manage this, we will prioritize high-value dream features and key system quality goals like performance, code clarity, maintenance, finalize the schema incrementally through collaborative reviews to ensure core system stability, test improvements safely using versioned schema drafts, and document updates promptly to keep the team aligned and enhance maintainability. The second risk is system architecture revisions for dream features and system quality with a medium impact but low probability. These adjustments may add complexity, potentially delaying non-critical milestones. To address this, we will design a modular architecture that aligns with prioritized schema goals to support performance and maintenance while minimizing rework, and document changes clearly to ensure team alignment and code clarity. The third risk is challenges in meeting coordination with a medium impact but high probability, especially since our teammates are spread across 4 different time zones around the world. Inconsistent attendance may lead to miscommunication, delaying decisions or system quality improvements. To mitigate this, we will maintain the shared Notion page I created and wrote with updates like system architecture, issues and solutions, testing methods, and to-do lists. Use team calendars to coordinate availability. Activate transcription mode in Microsoft Teams, our main communication tool, to capture discussions. And shift weekly meetings to earlier in the week to allow more time for preparing code deliverables. Fourth risk is uncertainty in client graphical user interface technology selection with a low impact but medium probability. Learning an unspecified UI technology for further improvement may slightly delay enhancement for dream features. To address this, we will dedicate 1 week in advance to select the UI technology for usability and efficiency, followed by a brief training session if needed. Assign tasks based on team skills to minimize learning curves. And we were considering splitting UI tasks either by feature to speed up development, though it depends on individual skills, or by component, though it needs more collaboration, deciding based on the team's skills and timeline. Now, let's move to the schedule updates. We have 3 weeks left to prepare for the target system increment demo on May 5th, which will be the key showcase of our project. Here's our plan. In week 1, we will update the database schema and system architecture, finalize the client UI implementation and text, and select the graphical user interface technology. In week 2, we will develop the GUI, implement the dream features, and begin testing and debugging with both white box and black box approaches to ensure reliability and ready for the demo. Finally, in week 3, we will prepare for the demo, ensuring we have enough time to showcase our project effectively, continue testing and debugging to polish the system, and conduct a peer evaluation to reflect on our work.
The expectations Team Alpha has for the target increment demo are as follows. The server should be able to broadcast game state changes to all players, such as when a character moves, a suggestion is made, disproven, or unable to be disproven. Multiplayer functionality should be reviewed so that all players of the game can seamlessly play the game together without any interruptions or conflicts. The graphical user interface should be revised to make the game board more similar to a real board game played in production. The team will add these expected features following the schedule outlined in the schedule updates section.
Before we move on to our demo, I wanted to thank my teammates Hinjin, Leah, Ria, and Josh for all of their hard work designing and implementing our online Clueless game to help bring people together to play a simplified version of the board game Clue. Our demo hosted by Josh will showcase the progress we have made since our skeletal demo, showcasing our improvement to the game logic subsystem, allowing the game to progress as intended, our updates to our database subsystem to retain the player's information, and the current state of our networking subsystem. Our UI still needs some tweaks to match our desired design, and there are some communications that can be improved for broadcasting to all players. As discussed before, we have crafted our schedule for when we would like to resolve these tasks laid out previously, with our greatest desire to resolve the risk of not reaching out the other users on various networks. We are quite pleased with our progress with our game logic and database subsystems, and are on track to now shift some of our focus to our network subsystem, with some of our focus remaining on creating tests to gain more confidence in the communications between these subsystems. All things considered, we are looking forward to the next steps and any feedback you can give us. Thank you.
Hello, my name is Joshua Delosa, and I will be presenting the Minimal System Increment demo for the Clueless game by Team Alpha. I will be covering any changes, updates, and added functionality to the game since the skeletal system demo presentation. The base architecture of the game remains the same, but there has been a lot of added functionality and quality of life updates. The UI has been greatly enhanced, and we now have a light and dark mode implemented as an added feature. We are currently in dark mode, and this is light mode. For the purpose of this demo, I will be in dark mode most of the time. So to start up the demo, I would like to demonstrate signing up for the game first. In order to log in, you need to make an account. So I already have 3 other accounts made, so this one will be player 4. Once I've signed up, the game will tell you that you've signed up successfully and that you can log in with that player now. I'm now going to log in with a player. As you can see, rather than put us right in the game will now put us in a starting lobby. We can't start the game unless there's more than 2 people in the game. Upon login too, the player character is assigned a character, in this case Mr. Green, put in a location, and it's set to true. And now I'm going to log in with player 2. As you can see, player 2 is now in the starting lobby, and the lobby has updated from 1 player to 2 players. We can also see that with player 2 now logged in, the game has been updated. In game 1, we have 2 players. Player 2 is assigned Miss Peacock, location hallway 8, and also says true. Player 3 is now in the game, and we see the current player has been updated to 3 out of 6 players. and we can see that the game is updated again. Player 3 is Professor Plum, location hallway, and is true. So now we'll add the final player into the game. Player 4. Our lobby's updated, and now we can start the game. So now that we're on the actual board with all the players, there are a few things that get initialized upon startup. First is that all the suspects, weapons, and rooms are put into a deck and shuffled. The case file then pulls one suspect, one weapon, and one room and saves it in the case file. The remainder of the cards are then distributed amongst all the players evenly. I'm now going to move with Mr. Green. First, I'm going to move to a non-adjacent hallway. As you can see, the game stops me. However, I can move to an adjacent room, no problem. We can check the message traffic and see that Mr. Green, his initial location, is now changed to ballroom after that movement. So it's still Mr. Green's turn. We'll try to move again. Let's see if the game prevents us from moving again. I'll then try to move with player 2 to see if he can move. And the game prevents us from moving for that player. One of the new features we added is the end turn button. We incorporate this end turn button to handle the character's turn orders. So now I've ended turn on player 1, it's now player's 2 turn, and player 2 can now move. Now that it's player's 2's turn, we can move. And you can see that it's also updated in real time on all the characters' boards. Here's player 4. I'm going to end player 2's turn now. Player 3. I see I can't end turn without moving. End turn. And player 4. Another feature we implemented is these suggestions. So I'm going to move Mr. Green to the hallway and attempt to make a suggestion. As you can see, I cannot make a suggestion unless I'm in a room. I'm going to end my turn as Mr. Green and move on to the next player. So as we can see from the suggestions, we have all the players and the weapons. I'm going to select Mr. Green as a suggestion, submit. As you can see, when I made the suggestion, the character moved to the room I was in. And then we can check the message traffic to see if my suggestion is disproved or not. And we can see that Mr. Green knife library, and player 3 has a Mr. Green card, so it's disproved. The way the game checks if a suggestion is disproved is that it will iterate through all the players' hands and look for that card. If it finds a card, then that will disprove the suggestion. The final incorporation of the game is the accusation button. As long as the player's turn, they can make an accusation whenever they want. So now we can check against the case file to see if my accusation was right or not. And we can see that my accusation of Miss Scarlet knife in the study and what the actual case file has. So my accusation was incorrect. So now I'm going to go to player 2 and make a correct accusation. And here we are. And we can see here that my accusation is correct, and we've won the game. And that concludes the presentation for Team Alpha's minimal system increment demo of the Clueless game. Thank you for your time.